Okay, we're going to talk about the final two anomalies here. The first is to do with small probabilities, and the second is the endowment effect. So here's a question. We've got two more choices that we're going to contrast with each other. Firstly, there's a choice of £6,000, which you get with a probability of 0.45, versus B, where you get £3,000 with a probability of 0.9. So notice what's happening there in that first choice. You have 6,000 versus 3,000, so you've got half the amount of money in option B, but it's occurring with double the probability. So 90% chance of getting the 3,000 versus 45% chance of getting the getting the 6,000. Now contrast that with choices C and D, which is option 2. There you've got £6,000 with a probability of 0.001, okay, so a 0.1% chance, or £3,000 with a probability of 0.002, or a 0.2% chance. So the question here is, again, what do people choose? If you're confronted with those choices, option A and B, pick one, and then option C and D, pick one, what do you pick and why? So think about that for a second. Well, here, let's think about it and see what people actually do. Most people choose B and C. So notice what's happening here. They're choosing the £3,000 with a probability of 90%, with a corresponding 0% chance and zero payoff with 10% chance. And when we think about that, they're choosing that, but then when it comes to the probability of 0.001 and 0.002, what do we see? They're picking the 6,000 with a probability of 0.001 versus the 3,000 probability of 0.002. So what's happened there? We still have that scaling. The 3,000 is occurring with double the likelihood that the 6,000 is. But what have people done? They're choosing the 6,000 rather than the 3,000, even though it's occurring with half the probability that the other one is. So what is happening here? This is a violation of independence, right? So when we think about this, we have to contrast a couple different choices. So if we think of X and Y as the two different values that people could get, X and Y, the 6,000 and the 3,000 respectively. But then if we take P as the probability of 45% and P times Q, what's happening there? People are, oh, sorry, I got that in the wrong order. So we have X and P. X and P, that's the 3,000 occurring with a probability of 90%. You're getting greater utility from that than you are from the utility of 6,000, than from 6,000, which is occurring with that same 0.9, but then multiplied by 1/2, right? So 0.9 times 1/2 is 0.45. So that's what we have in that first set of choices, XP versus YPQ. That's 3,000 with probability 0.9 versus 6,000 with a probability of 0.45. So that's showing that preference choice there. But then now what's happening? We've got, in the second case, X still the 3,000 with the probability of 0.002. That is now less preferred than 6,000 with a probability of 0.001. Okay, now what that means is that we've violated independence. So we've violated one of the things that we need in order to have someone who's an expected utility theory maximizer, or expected utility maximizer, sorry. And so this means that people once more have a preference reversal or a contradiction. And so this suggests that they're like irrational or not rational, or their behavior is inconsistent with expected utility theory. So what this suggests to us is that small probabilities could be playing around with people's expectations of what to do here, or what to do in these different circumstances. Okay, so the final anomaly that we need to understand is the endowment effect. So Kahneman, Knecht, and Thaler in 1990 ran an experiment where they gave people some mugs. They endowed them with mugs, so they did an experiment with this. Now, so willingness to pay is the maximum price an individual wants to pay for a mug. Willingness to accept is the minimum compensation demanded by the owner to sell a mug. So if I have a mug and I think about selling it to you, right, then what happens? You give me some money, and then if it's greater than my willingness to sell, then I'll sell it to you. If on the other hand, it's not as great as my willingness to sell, I will not sell it to you. My willingness to accept, sorry. Now, the standard assumption implies that willingness to accept is going to be equal to willingness to pay in some kind of competitive equilibrium. So, what do we see? Some subjects were endowed with a mug worth $6. So that was back in 1990, right? So quite a nice mug. Now, subjects were then told to bring money into class and that credit and change would be available if necessary. Now, the experimenters then elicited willingness to pay and willingness to accept from the different participants in the experiment. What they saw was that the median willingness to pay for a mug was $2.75, even though people knew that the mugs were worth $6, and that the median willingness to accept was equal to $5.25, $5.25. Now, that means that willingness to pay was not equal to willingness to accept in this market of people engaging in these interactions. Now, similar experiments have been conducted in other places with pens, folding binoculars, lottery tickets, and other kinds of things. And what you see is that in many cases, willingness to pay does not equal to willingness to accept. Now, expected utility theory implies that agents have a stable utility of the underlying good that we're talking about, such as a mug or binoculars or lottery tickets or so on, which implies that willingness to pay should equal willingness to accept. So why was willingness to accept greater than willingness to pay in this experiment? Now notice this means we're not going to get an efficient outcome in the markets. If people have some belief that their willingness to accept is greater, or they know that their willingness to accept is greater than other people's willingness to pay, what's going to happen there? People aren't going to engage in exchange. When people aren't engaging in exchange, we're not going to get mutual gains from trade, right? Because it has to be the case that someone else is going to want my mug and then buy it from me, and that I'm going to be willing to accept a certain price and then benefit from that as a consequence. But we see that that doesn't happen in this context. So what we have to think about here is that there are two implicit assumptions that we sometimes have to overcome and think about in behavioral economics. Firstly, this one assumption is that utility is defined over final consumption rather than gains and losses relative to a reference point. What do we mean by that? Okay, so expected utility theory says that people talk about the final consumption value, such as that $6,000 or $3,000 that we spoke about earlier, or 6,000 or 3,000 pounds, sorry. Now, those are absolute numbers, right? Those are absolute numbers. But when we think about then the little probabilities that we had, the 0.01, the 0.02, how do we interpret those relative to each other? Do we interpret those relative to each other in the same way that we interpret the difference between 90% and 45%, that doubling of probabilities, versus the doubling of probabilities of 0.002 to 0.001? Do we treat them in the same way with that doubling? Why or why not? What's going on there? The other point is that preferences are independent of the way in which prospects are described. So what this is saying is that we should not care about the way in which a prospect is described when we're making a choice between two different prospects. So when we spoke about that choice right at the start with the disease, and we spoke about saving people versus people dying, that kind of framing, that kind of description of the prospect should not change how people behave. But what we see instead is that those kinds of descriptions change how people understand the underlying context of the choice. In the one case, it's, I can save, I can gain this much benefit. On the other hand, it's, oh my God, I'm going to lose these people who die. So notice how you're changing that. The one is a gain, the other one is a loss. And people can behave differently over gains versus losses. And that intuition is something that's going to frame how we understand prospect theory later in this section.